Okay. Yeah, much better. Perfect. Okay, so we're looking at the second worksheet now. Yeah, and I'll probably do something like number 1 as an example to help us here. Okay. Right, okay, so let me start off with a little bit of a drawing maybe. So there's my object. And it's not moving. Okay? Not moving. So if it's not moving, how much force is going to the right? Yeah. Let's just say the total be 0. And how much force is going vertically? 0. And if it's not moving, how much turning force is there? 0. 0 newtons, 0 newtons, and 0 newton meters. Now, what word can you think to use to describe this? Do you know what I mean? What word would you use to
describe what that's going?
This situation where it's not moving, it's completely fixed, non-moving. What word could you use to describe this? Any ideas, anybody? What's that?
Rest.
Huh?
Rest.
At rest, but something more advanced. Because, for example, I could say this is at rest, even if it's turning, because it's not moving, you know, so we need something a little bit more than at rest.
Station.
Yeah, we're getting closer. Not quite stationary, but we're getting closer. Any ideas?
Motionless.
Motionless. I'll show you the word here. It's this. Equilibrium. That's the word that means not moving or not rotating, not turning. So if I tell you it's in equilibrium, what does it mean?
It's not moving.
Continue, not moving and
Turning.
not turning. So is this cup in equilibrium?
Yes.
Yes. Is it in equilibrium now? No. It's not moving. I mean, it's not going this movement, but it's turning. Okay. So equilibrium means absolutely at rest. Not turning, not moving, nothing. Completely balanced. Okay, so have you heard this word before, equilibrium?
Not yet.
Not yet?
Yeah.
Now you have.
Yeah.
Okay. Oh, I thought I could paste it. Anyways,
That's the name of the
equilibrium. Yeah. Here, do you need the spelling? Equilibrium. Here, I'll write it bigger for you so you can see. Okay. EQUILIB. What did I say? BRIUM. Yes?
Mm-hmm.
Okay. And that's it. Simple idea. But now let's look at an example of using this idea, and we see this idea is so useful for problems. Okay? So here we go. What we might call a real world example. Okay, so let's say we're building a bridge. Okay. Let me try and draw. There we go. We build a bridge. And on this bridge, it's held up by 2 steel cables. Okay, so one here and one here. Okay, and let's say there's a car, and let's say the car is here. And how big do you want to make this bridge? How big will we make it? We'll make it a small bridge. Maybe 100 meters?
You mean
Yeah.
the length? Or
Yeah. Let's say it's 100-meter bridge. How heavy will we make it? The weight here in the middle. Maybe 20,000 kg?
Okay.
20,000. Let's say 200,000 newtons is the weight.
Okay.
Yeah? And let's say here is T1 and T2. Okay. Firstly, the car actually. How heavy will we make the car? How heavy is a small car? Let's say it's a Yaris. 100 kg? No. That's too light.
It's not like people who clean the window out of the building.
No, it's a bridge.
No, I mean the other another example. It's not like that.
It's a bridge. It's like that, yeah. And it's a bridge and it has 2 cables holding the bridge up.
Like the people who
Like
clean
that.
the building, there's a
Yeah.
tool and
Yeah.
weight and the people.
Exactly. Yeah, exactly. Yeah. Okay. How heavy will we make the car? I don't know. 500 kg? So we'll say 5,000 newtons? Okay, 5,000 newtons. And how far away should the car be from the start of the bridge?
What?
Let's say 10 meters, yeah?
What's that?
How far the car is from the start of the bridge. And the bridge in total is 100 meters. Okay, so we would like to know, as an engineer, this is a good engineering problem. As an engineer, we would like to know how much tension, how much force is in each string. How much strain, how much force is in each string, each cable. Firstly, before we start, which one do you think will be bigger? T1 or T2?
T2.
Why T2?
The car.
The car is nearer to this, so this one should have more force in it. So let's calculate it, okay? Is the bridge moving? No, it's going to be in equilibrium. And let's pretend, let's make our life easy. Let's say the car has stopped. It stopped. Maybe it broke. Maybe if it's a Nissan Micra, a Fiat Punto, a Nissan Micra, maybe it broke down. Something like this. Okay, so what's the total force going up here?
What? Going up?
Yeah.
T1 plus T2.
T1 plus T2. And what's the total force going down?
W plus car.
Yeah, which is going to be 2,000
Plus 5,000.
plus, so 205,000 newtons.
Okay.
Now what's the force left and right? There's no force left and right.
It's equilibrium.
Yeah. So I need to find T1 and T2, but what's the problem? I only have one equation. So where do I get my other equation from? From the turning force. What's the turning force here? What's the total turning force? No, the number. What should it be? Come on. No, come on. What is it? Total turning force. What should it be? 0 Newton meters. Right? Is this turning?
No.
No. So what should the turning force be?
0.
0. Okay?
Okay.
Are you sure?
Yes.
Alright. Is this okay, Leslie?
Yeah, okay.
Now, where will I place my origin?
And T1?
It doesn't really matter. Yeah, let's place it here at T1.
0.
Now, I didn't tell you yet, but let's say it's 10 from here to here, And then let's say it's another 10 from the car from here to here. And then let's say from here to here, let's say
50?
that's, yeah, 50. Why not? It's 50. And then here to here,
30.
30. Okay, and let's take this as our origin. So the first turning force
0.
will be 0. The second one, what's the distance from here to here?
50, 25.
Now be careful, this isn't in the middle of these two, it's in the middle of the total.
Middle.
So this is at 50,
50, okay.
this is at 30. So this distance here,
50.
yeah, what's this distance?
50.
No, come on, what's this distance?
25.
No. Come on, what's this distance? Ted, what's this distance? Leslie, what's this distance?
70.
20.
Thank you, Leslie. 20.
Why?
What do you mean, why? It's 50 from here to here,
Okay.
and 30 from here to here.
Okay.
Okay, just think for a moment, yes?
50 from T1 to T2.
That's it.
Yes, but the total is 100. And this will be in the middle at 50. Yes? Okay. Is this okay? Ted, are you okay? Ted, you look unhappy. What's wrong?
Nothing.
Are you sure?
Yes.
Go on, if you have a problem, tell me.
The 50 is two.
Between this string and this string,
Yeah,
yeah.
let's make it 20 here, 20 here.
No, I'm not
40
going to
here.
change the numbers. We'll keep it like this.
But the middle is the 55. 25.
The middle here?
From here.
No, this is not the middle of this and this. Not the middle. This is the middle of this and this.
Alright.
So it's not, yes, you think it's 25 and 30. Not this. Here to here is 50. Here to here is 30. So here to here is 20.
Alright.
It's okay? Alright. Good. No, good. Alright, so the turning force for this is 0. What's the turning force for this?
200,000 minus
Minus
200,000.
200,000
Multiply.
multiply 20. And then from here to here, how much is here to here? How much is here to here?
40.
How much?
50.
50, thank you. 50 multiplied by T2. And then from here to here,
It's 10.
60
Oh,
multiply 5,000.
that was 16.
50
Okay.
plus 10.
Okay.
Okay. Now, that will be 4,000,000 plus 50 T2 minus 3,000,000. 300,000. And what should that equal in total?
0.
0. So I get 50 T2 should equal,
400,000 minus 300.
I think this is actually 4 million.
Oh,
Yeah. So that will be 3,700,000. Yes?
I think so.
I hope so. Cancel 0. And I get T2.
We will get 2 and find T1 from them.
Yeah. What's T? Divide this by 5. 5, 7, 4,000,000. 3 zeros, not 4 zeros.
Shouldn't the 337 40 shouldn't be like
Negative here?
Then bring over the phone and
No.
Oh, you're right. Sorry, Mustafa. Sorry, Albert. Yeah, you're right. I forgot the minus sign here.
Why?
Hmm?
Because 4 million minus 3.
Yeah, it's minus.
Why?
Because this goes over to the right, becomes minus 4 million. So that should be minus this.
Yes, here.
So T2 is minus 74,000. Why is it minus?
but you are treating the downward force as
Yeah.
negative. Why is that?
No, I'm treating the downward force as positive.
And 200,000 is negative.
Yeah, but I put it in as positive. The only reason I wrote the negative was because it was clockwise. Like here, I suppose. Yeah. Maybe I should draw this at the start.
Opposite direction.
Yeah, for me, I'm doing it like this: positive, negative, positive, negative. Yeah, I'm sorry. I should have done it the other way. In fact, it doesn't matter because in the exam, they'll ask you for the magnitude
So,
anyways. So the magnitude would be 74,000 newtons. Okay. Now I can use this to get T1.
Yeah, I'll turn on that side.
So T2 is add that to the other side. What do you get?
We will get 131,000.
Wait, did I do something stupid here now? Because which one should be bigger? T2. T2 minus T1. What did I do? I think I made a sign mistake. Clockwise, negative, anti-clockwise, positive, clockwise, negative. Ah! Last. Oh! So, now I have to delete this. So Mustafa, can you do, oh actually no, I don't really need to do it because I can add it up. Alright, let's fix that stupid mistake. 50T2 equals that and that. 4300000 and divide that by 50.
86,000. 86,000.
4 zeros?
Yeah, 3.
Okay. Now, if I put that T2 in there, so Mustafa, 205,000 minus 86,000.
291000.
No, minus. 205,000 minus 86,000. Should be 1 something.
Okay.
It should be 1.
205,000 minus 86,000.
19.
11,90,000. Yeah. Okay.
So I have T1 and T2 now. Yes? I'm very sorry about this mistake here. So please ignore my ridiculous statement earlier, Albert, where I said this here.
And Mr. Stephen.
That's still positive, that's still negative, that's still positive, and that's still negative. Yes?
Mr. Stephen, you know a bookstore named Readers. Have you ever been there?
Can I see
What's
the
it
drum?
called?
Can I see the drums? See?
What's it called?
Readers. Or some bookstore you can introduce me to buy some physics exercise because I want to know some solution so that I can practice myself at home.
Do you have a credit card? Could you buy on Amazon?
Yeah.
Amazon, you know Amazon?
A book, a store online.
Yes.
Yeah.
Why don't I just send you the link of the book from Amazon, and then you can
Okay.
see if it's in the bookshop,
Uh-huh.
and if it's not in the bookshop, you can buy it from Amazon cheaply.
Okay.
Can you email me, and then I will reply with the link.
Okay. No problem.
Maybe you can do that this week, maybe tomorrow or something.
Okay.
You can buy it from amazon.co.uk.
Okay.
So it should only take 1 week to get.
Uh-huh.
Okay?
Okay.
Right, I'm sorry about that mistake. Is this okay now? You are writing this down, of course, aren't you, Ted?
Yes.
Of course.
And from T2 to T1 is
50 meters.
no T2 to T1. Yeah, 50. Okay. So can you go down a little bit?
Mm-hmm. Oops. You want the calculations now? What happens when the car moves to the left?
To the left.
What happens to the tensions?
In T1, T2 will be what?
T2 will get
Bigger.
bigger. And T, hang on, which way do I have it around on my diagram?
Right.
T2 will get smaller and T1 will get bigger.
Yeah.
Wait, did I write this the wrong way here? Let's have a look. I'm unhappy.
What? Can I see T2?
Ah, hang on. Yes. I said at the start T2 should be bigger, but it's not. It's smaller. Why is that? I thought I made a mistake, but then I realized I didn't.
Because the car is too heavy, will be.
No. I said T2 should be bigger, but it's not. Why not? And there's a good reason why not. Why is T1 bigger?
Because yeah, because it won't be imbalanced if T2 will be bigger and the car the average will fall down.
No, come.
Because the distance of T1 is smaller.
Thank you, Leslie. Very good. T1 is 20 meters from the center. T2, how far is T2 from the center?
Not 30.
30. So which one is closer to the center? T1. So T1 is supporting more of the bridge. Now, isn't that interesting? No? The bridge is so much more heavier than the car that it's much more stressful to support the bridge than the car. So that's why T1 being to the center puts it under more stress. Okay? So you see, it's very, very good now to think at the start of the question which one you think should be bigger. And then if it's not what you think, then you have to think carefully about why. Did you make a mistake, or is there something that you missed?
I think you missed.
And in here was something I missed. T1 is nearer to the center of the bridge, it's supporting more of the weight. Okay?
The distance of T1 and T2 is the same from the center. Can we say that T1 and T2 is equal in force?
If there was no car?
No, I mean if, yeah, there's no car.
Yes.
But if there is a car, it won't be equal.
Yes.
Even though their distance are
Yes. Correct.
See, we'll start the exam now.
Let me just do one more small example, okay?
Oh, it won't be. Oh, okay. Can I go bathroom? I'll go bathroom.
Okay, but I'll have to start the example, okay? Right, number 2. Let's make up some example. We did a bridge. What would you like to do now? Anything else from engineering?
Building.
A building, maybe?
No, that's the thing. They wash it in the building.
You want to do the guy washing the building? Alright, okay, why not? Alright. Here is, you see the people washing the buildings? And he has a rope. There's rope 1, T1, and there's rope 2, T2. And let's say here is 1 meter, 2 meters, 1 meter.
what would be?
Yeah, 1 meter from here to here, 2 from here to here, and 1 from here to here. And let's put our man, let's put him hanging here. He's going to fall. Okay? And let's say, how heavy shall we make our man?
100 kg.
Yeah, let's make him a bit heavy. So let's say 1,000 newtons, okay? And let's say the distance is another 1 meter. Okay? Now, again, which one do we think will have more tension? T1 or T2? Which will be bigger? I think T2 should be bigger, yeah? Now, let's make this 10,000 newtons.
Sorry, Mr.
Yeah.
Why T2 is bigger?
I think it should be bigger because there's more on this side, like the man is here.
Oh.
So there's more here.
He added the weight.
Yes.
Okay.
Alright, what's the total up? T1 plus T2 should equal 11,000. And then the turning force. Let me take this as the center. Okay, so the first one will be 1 multiplied 10,000, and it'll be negative or positive? It'll be negative. And then the next one is this here, which will be 2 times T2. And then the next one will be the man, which is negative 3,000. And that should equal 0. So I get 2T2 equal to 3,000 and 10,000. That's 13,000, yes? So T2 should equal 13,000 divided by 2, so 6,500 newtons. Yes?
Yeah.
And then T1, that should equal 4,500 newtons. Yes? So we've gotten the tension. And which one is bigger?
T2.
T2. Alright. Shall we make this a little bit more difficult now? Let's add something extra. let's say I want to add something to this. Sit. I'm thinking like a bird or something like this. I know what we'll add. Let's say your teacher is here. Okay? Let's just say he's, I don't know, floating on something. Okay? And I come along and I start to turn this. So I start to go to try and make him fall off. Huh? Bad teacher, yeah. So I try to add more force to it. So let's see. Let's say I try to turn it, and let's say I try to add a couple, and let's say the couple has a turning force of 1,000 Newton meters. So I come along and I start to try and turn it. How will that change the tension? Well, will this still be 11,000? No, it will be, because remember, couple, the net force is 0. So T1 plus T2 is still 11,000. What does change though? Yeah, the turning force. Okay, so now you get minus 10,000 plus 2T2 minus 3,000, and let's say I try to turn it so that I turn it clockwise, so that would be minus 1,000. And what should that equal still? Should still be 0, because let's pretend I turn it but I am not strong enough to move it. So now I get a different answer for T2. T2 will equal 2T2 will equal minus will equal 14,000, isn't it? So what will T2 equal now? 7,000 newtons. So can you all picture what happens? You have the window cleaner. The man is holding on. What's the tension in T2? 6,500 newtons. Then your teacher comes along. So let's pretend this here. Let's pretend this is the window cleaner. Okay? And the man is hanging here. Okay? And I come along and then I grab it and I try to turn it. But I'm not strong enough to turn it, so I'm just going to try. Okay? And when I try to turn it, it doesn't move, but what happens to the tension in the string? It gets bigger because I'm trying to turn it, you know? And if I keep turning harder and harder and the tension gets bigger and bigger, eventually what will happen to the rope? It'll snap. Now, what happens if I turn it the other way, if I want to help him? So this here is positive, so is that clockwise or anti-clockwise?
Anti.
That's anti-clockwise. Now let's pretend I'm going to be helpful. Okay? And instead I turn it the other way. Well then this 1,000 becomes minus 1,000 if I turn it the other way. No. Before I turned it 1,000. That's clockwise or anti-clockwise? Anti-clockwise.
Clockwise.
No, 1,000.
So you are trying to doing this to man fall down.
No. Listen carefully. 1,000 Newton meter turning force is positive. Is that clockwise or anti-clockwise? Anti. Now let's pretend I do the other direction. So I do it the other way, clockwise. So now it's negative. So this will become minus. So this here, what will this change?
Plus.
Sorry. It was minus.
It was minus, now it's positive.
Now it's positive.
I'm telling you.
Thank you. Okay. It was minus, now it's positive. So this here becomes positive. So this isn't now 14,000. What will it be?
13, just a minute.
It'll be 12,000. Right? 2,000 and 10,000.
Okay.
So what's the tension? It'll be 6,000. Okay? So I can, if I want to help him, should it be positive or negative?
What?
If I want to help him,
What?
positive. And if I don't want to help him,
Negative.
negative. Yeah, I think that's enough. So which will it be? Helpful or unhelpful? Helpful? Oh my goodness. Alright, helpful. So what did I say? Positive. So we'll keep it as positive then.
Well, 6.
When you start learning about applying statics, you
Yeah, pretty much. Pretty much, yeah. Okay. Are you happy with that? You like that example?
Yeah.
And you can make these things more difficult, you know, then you can say like a
bird.
bird sits here. What happens to this tension?
You're happier.
It gets heavier. And then you could say 2 birds sit here.
Even.
Maybe try to cancel it. Okay, but then I'm just being silly now. Alright. If we start the exam now, but you'll have to try those questions at home. I won't have time to do them in the next class, okay? So you need to try that worksheet at home for sure.